A farmer wants to create a pig pen. The pen is to be rectangle divided into 3 smaller rectangles with sides parallel to one of the sides of the larger rectangle. He has exactly 300 feet of wire to create a pen. Find the dimensions of the pen with the largest possible area. I've already drawn a picture of what this pen is supposed to look like. There are 3 small rectangles, and the sides on the inside are parallel to the sides of the larger rectangle. We already know that there are 300 feet of fencing. So I'm going to call this the perimeter. The 300 feet of fencing needs to cover 1x, 2x's, 3x's, 4x's of fencing, and 1y and another y, so 2 y's of fencing. It needs to cover all of that length. The area is trying to be maximized. The area of the entire rectangle is x times y. In order to optimize this equation, we need to solve the secondary equation for one of the 2 variables and substitute that result into the optimization equation. When you solve this equation for y and simplify, you will see that you get 150 minus 2x equals y. Now that this is solved for y, this expression can be substituted in for y into the optimization equation, giving a equals x times 150 minus 2x. Now that the optimization equation is in terms of one variable, we can find a feasible domain. And just by looking at this picture, we know there has to be some length to this x value. So we know that the x needs to be bigger than 0. But since there are 4 x's and 300 feet, each x at most, since they all have to be the same length, can be 75 feet. So if we find an x value outside of this domain, it is not a good answer. Now that we have this, I want to simplify this area equation just a little bit more by distributing the x to each term inside the parentheses to get that a equals 150x minus 2x squared. Now that this is accomplished, we can find the derivative. The derivative of the area is 150 minus 4x. And if you set this equal to 0 and solve for x, you will see that x equals 37.5 feet. So 37.5 feet will be the length of each of these sides. What's left is to find out what is the dimension of y. And when you take this value and you substitute it back into this equation for x, you will see that y equals 75 feet. Here are the dimensions which give the largest area to the pen.